Alright, Chapter 2 Summary. The information that's on file is summarized the important points presented in this chapter. Use the microwave frequencies force developed in the special tubes to offset with the limitation caused by the inner electrode capacity, lead inductancy, electrical transit times, effect for the potential in the tube, the microwave tube, such as the klystron and the transfer to wave tube. It takes advantage of the transit time effect through the velocity modulation to amplify and generate microwave wave energy. The klystron is a velocity modulated tube which may be used for amplifier or oscillator. The klystron is used when amplifier requires at least two resonant cavities, the buncher and the catcher. A diagram of the basic klystron is shown on the right. Shown at the right. So for the glass type, it's metal and feedback grid, cathode, buncher cavity, input, draft space, output cavity, input, cathode grid, control grid, accelerator, input, resonated cavity, buncher grids, bunch, electrons, feedback, output, resonant cavity, cathode grids, cathode, collector, anoid, blade. The reflective klystron shown to the right is an oscillator used only with a cavity bunch of the collected electrons. The frequency determines the size of the shape of the cavity. The klystron has several possible modes of operation will determine the electron transit time. Electron transit time is called the repeller voltage. Or show the propeller, reflector plate, grid graphs, resonant cavity, output magnetic coupling loop, accelerator, grid, and cathode resonator potential. The TWT or transfer wave transfer wave tube and the wide bandwidth velocity modulate tubes are used for properly used as an amplifier electron beam. The produced bunch with a simple pile applied with the helix. Bunch case for the energy transform electric beam with the traveling wave of the helix. The magnetron diode oscillator capable of delivering microwave energy at very high power levels. The three fields exist for the magnetron influence of the operation. DC electrical field between the anode and cathode. AC electric field produced oscillation resonant cavity on the same plane as the DC field. Magnetic field produced by the permanent magnet, which is perpendicular with the DC electrical field. Magnetrons are two basic types, the negative resistant magnetron and the electron resonance magnetron. Diagram of the magnetron is shown at the right. The cathode pickup loop, the other conductor coaxial line, glass seal center conductor coaxial line, alternators plate segment together, mounting flange interaction, cathode and filament lead glass seal resonant cavities. Your solid-state microwave devices are becoming increasingly widespread with the microwave equipment. The new develops almost every day. Most of the current available solid-state devices are two-terminal diodes with the capability of generating and amplifying microwave energy. Many of the solid-state devices, such as the tunnel diode and the bulk effect diode, apply the property of the negative resistance to amplify the microwave generated of the microwave energy. A characteristic of the curve of the negatively resistant property of the tunnel diode is shown at the right. Current flow, peak point, negative resistant region, valley point A, B and C, A, B, and C. Voltage vector is a two-terminal diode that acts variable capacity as a variable capacity and active element with the panoramic amplifiers. Panoramic amplifiers are the low noise microwave amplifier. Those with the variable reactancy to apply microwave signal. The illustration shown is the example of the non-generative parameter amplifier. Alright, the unused port, the dummy load, the applied FS single output, FS single input, ferrite circulator, FS output, input, and output. Signal cavity FP pump with the 12 gigahertz signal is idler cavity vector diode reverse bio battery. Unused port on dummy load, applied amplified FS single output, FS ferrocircular, FS input and output, 3 gigahertz signal tank, 3 gigahertz, FS pump, 12 gigahertz signal input, idler tank, 9 gigahertz, voltage control, and capacitor vector. And that was chapter 2, summary.